Welcome back to this Python Extension 1 series. This is a continuation video of the Model 2. So in this video tutorials, we're going to be looking at basic Python operators, and as you can see right here on the screen, just like in mathematics, we have the addition, which is the plus sign, the subtraction, which is the minus sign, and this asterisk over here is used for multiplication, and the slash is used for division. The double slash is the floor division, which is division to whole number, while the percentage sign here is a modulo sign, which is the remainder sign. For example, when you divide something together, what is the remainder, right? So here's exponentiation has to do with what power, right? So just let me just go ahead and bring up my VS Code. Let me go up and bring my VS Code. So let me just go ahead and clear this. So basic, you have your addition. You just print. Let me say 22 plus 2. Definitely this is going to give you 24. Print. Let me just go ahead and copy and paste that. So you just see addition and subtraction, division, multiplication. All right, so 2 plus 2, 20 plus 2, we have let me say minus. Here we have, let me do a divide, then let me do, all right, let me do this. So let me just go ahead and clear my screen, my console. So if you go ahead and run this over here, let's run this and see what we have on our console. So for the first one, we have 22 plus 2, which gives us 24. If you check on the console, 22 minus 2 will give us 20. 22 divided by 2 will give us 11.0. As you can see, this is giving us in float, right? Print 22 times 2. 22 times 2 is 44. So let me clear this. Let me clear this. So for this 22 divided by this, if we want it in whole number, we don't want that, we don't want remainder. For example, let me do 23 divided by 2 and 23 divided by 2. You see that one we this is the floor division. The one with double slash is a floor division. If I go ahead and run that, it's going to give me to whole number. That's why it's called a floor division. So as you can see right here on the screen, the floor division is the second one. It gives us 11. Then the normal slash gives us what, 11.5. So if you just want to divide something with a whole number, you don't want the remainder in it, then you can have this. So this the remainder for this is 5, right? It's 1. Sorry, the remainder is 1. So if you want to get the remainder of something, you use the modulo sign. It's called the remainder sign, modulo sign, whatever you want to call it, is a percentage sign. So let me just go ahead and print that. That should output 1 for us. So that is it. Let me print that out on the console. As you can see, we have 1 over here on the console. So this is just basically how you make use of this. So let me do the exponentiation. Let me do print. Let me say 2 raised to the power of 4. 2 raised to the power of 4. That's 2 times 2 times 2 times 2 times 2 in 4 places, right? So if you go ahead and run that, that should give us, I think, 16. Okay, yeah, that's it. So this is how you raise something to a power. So this is basically it about basic operators. So let me just go ahead and bring up the presentation. I don't know, so let's see what's next we should talk about. So, okay, there's what we call hierarchy of operators. I know in mathematics, you look at it in terms of BODMAS, whereby you have the bracket first, and the rest. So these are basically the hierarchy of operators in Python. So you have the parentheses having the highest precedence, then exponentiation, then when you unary, when you add negative or positive to a number, then we have the fourth one, which is multiplication. From multiplication, then division. From division, then floor division, then modulus. Then we have addition and subtraction following. After that, we have the bitwise shift. Then from there, we have the bitwise and we have the bitwise XOR and all. We have the comparison with equality, less or greater, and the rest. Then we have the logical, which is not, and then we have the or. then the assignment operator. So this is, just look at it, this is basically how it follows, right? Just the way it is arranged here. So this is how the hierarchy follows. So if you put 20 plus 4, let me just bring up our VS Code. So if you say print, let me say 10 minus 2. 10 minus 2 should give you 8, right? You now say times 2. 8 times 2 should give you 16, right? Logically, like if what you're trying to say is 10 minus 2, right? Which equates to what? 8, right? Then you now say that 8 now times, you see the 8 times 2, which is supposed to be equal to 16. But trust me, this is not going to happen. So let me go ahead and clear the screen. So let me just go ahead and run that so you see it on the console. Let me go ahead and run that. So this is basically it. Let's see what we get on the console. You see we get 6, and this is because it does not work the way it is arranged, right? But rather it follows an hierarchy of operators. So what happened here is that it first of all did 2 times 2, which is 4, right? Then 10 minus 4, which is what? Automatically there's an hidden bracket here that you can't see, right? So that's just what is happening because this has a higher precedence, so it follows that order. So if you really want to jam pack things up in a bracket like this, you can control the order of it. I think we'll get into that. So but in case we don't get into that, I will just show you a simple example, just the way you do in mathematics. You can do something like this to say, okay, I want you to do 10 minus 2, like separately. So this should give us 16, not 6, if we run this. So this, you can use bracket to change the order of things when you work with operators in Python. So if you go ahead and run this, you have an answer of 16, not 6. As you can see on the console, our answer is 16. So this is basically how you work with operators, you understand, and their precedence and all of that. So you can go ahead and do your practice and see how each and every one of those operators work. So let me just go ahead and bring back the presentation. So that's just basically how the precedence are. So the highest precedence is parentheses and the lowest is what? Assignment operators. So let me just go ahead and see what's next on the screen. So there's what we call operator associativity. So this term usually comes into play when you have operators of same precedence. So let me just bring back our VS Code. So imagine you have let me say you have an addition, you understand, and subtract. You have addition and subtraction. Yeah, those have same precedence. Let's just go back to the slide and let me check that out. So as you can see, addition and subtraction have the same precedence, right? So how does Python handles operators when they have same precedence? So now operator associativity specify the order, either handling the operators from left to right or in the reverse order. So when you have operators of same precedence, it handles it from left to right. That's exactly the way you've arranged it, right? Like arithmetic operators, bitwise operators, comparison operators, logical operators, all these are handled from left to right. So since we have addition and subtraction, let me just go to our VS Code here. So let's just go ahead and print, let me say 22 minus 10, then plus 2. So we are saying 22 minus 10, which is, if you minus 10 from 22, you're going to be left with what? I think this should give us 12. Yeah, 22 minus 10, that should give us 12. Yeah, I'm right. So 12 plus 2 should give us 14, right? So let me just go ahead and run that and see if my mathematical calculation is correct. We should get 12 on the console. 14, okay. Yes, so as you can see, it gives us 14. So what if I change the order? right? What if I change the order? Like, what will happen? So it handles this from left to right. It starts from saying 22 minus 12 minus 10, then adding 2 to it. Exactly. So what if I change the sign? It's still going to do the same thing. So still handle it from left to right, because addition and subtraction have the same precedence, the same level, like no one is higher than each other. So if you say 22 plus 10, right, minus 2, so this is 32 minus 2 should give us 30. So it's just going to handle it the same way from left to right. So this is how this is what we call operator associativity, right? So let me go ahead and run that. This should give us 30 on the console. So as you can see here, we have 30. So this is basically it from left to right. This is how Python handles operators that have same precedence. So this is from left to right. So when we talk about right to left associativity, so let's go back to our presentation and see what's an example of the right to left associativity. So we'll have assignment operators and exponentiation. So when you have exponentiation, it handles it from right to left. That's how it does it. So if you go ahead and bring our console, let me see. Okay. So I think the reason why this occurs is because it's really have there's no difference anyway when you have same let me say you have exponentiation of same exponent, like same operator, which is exponentiation itself alone. For example, you say 2 raised to the power of 2. So 2 raised to the power of 2 should give us 4, right? 2 raised to the power of 2, then you say raised to the power of so 4 raised to the power of 2 should give us 8, right? So let me just go ahead and run that on the console. So this is okay. Let me not use 2, let me use 4 here. So if you say 4 raised to the power of, it's going to handle it from here. 4 raised to the power of 2 is going to give us 6, right? 4 raised to the power of 4 raised to the power of 2 is going to give us 8. 8 raised to the power of 2 should give us 16, right? So let's go ahead and run that to see that it actually handles it from right to left. So if you go ahead and run that, I think we should have 16. If I'm not okay, what just happened? 4 raised to the power of 2. 4 raised to the power of 2. 4 times 4. Oh, 4 times 4 is 16. I don't know. let me do something. Okay, let me go ahead and print something on the console here. Okay, let me do 4 raised to the power of 2. 4 raised to the power of 2. Right? So whatsoever answer we get, we're going to raise it to another power of 2. So let's just see why that is happening. I don't know why I'm getting a huge number, trust me. So 4 raised to the power of 2 is 16. So when we raise 16 to power of 2, what should we get? Right, print 16 raised to power of 2. This should give us 16 times 16. I don't know if we should be getting so much of a huge number when you times 16 with 16. I'm not really a good mathematician. This should give us 256. So let me just go ahead and pause this video and see why this is really happening. You know, I say you can't have everything all figured out. So I'm going to go ahead and pause this video. All right, welcome back. I was able to figure out what was really happening. You know, sometimes these basic operators in Python might be a little bit tricky and, you know, get you on your toes. So if you look at it, basically, the error we're having here is because when we talk about right to left, it takes it in this way, like 2 raised to the power of 4. right? That's the mistake we made. So not 4 raised to the power of 2, not the reverse. So it takes it from right, like the way it is arranged like this, but from right. So we do 2 raised to the power of 4 first. So it does 2 raised to the power of 4. It handles it this way, right? So this is the first part. So this is the first part. So it does 2 raised to the power of 4. Then it will now do 2, which is this 2 raised to the power of the answer we're going to get here, which I think is going to be 16. Right, so if you print this out, it's going to give us exactly the same results from the first one. So that's just basically what happens. So when we're talking about right to left, this is what is happening. So if you see here, we have the same results in the first and second one. So from right to left, it takes this first, let me put it in brackets, so you see exactly how Python is handling it. So this is how Python handles it. It takes this 2 raised to the power of 4 and run it. So when it finished running it, the answer will now be 2. This 2 now raised to that answer. So this is exactly what Python is doing. So this is how from right to left work when you talk about associativity. So let's just go back to our slide. So just know that as you program, even some basic stuffs that you already know might give a little bit of issue, which you have to probably search through the internet to understand what's happening. So that is how you troubleshoot. So let's just go back to the slide. Let's go back to the slide. So what we are going to be looking at next is operators and parentheses. So I've already talked about this, so I'm not going to go into this again. I say that the use of parentheses in operators is usually meant to change the order of calculation, specifying how you want the program to be handled. I've already done that, whereby I use parentheses to change the order of precedence. So we're not going to go into that again. So we're going next into our variables in Python. So personally, I see variable as a placeholder for all kinds of data types in Python. So I think we've used variables before, where we set something to something, right? We have a name and we set something to that. So anyway, that's not that. So based on my definition, there are 2 key concepts in variable. A variable must have a name and it must have a value. This is very important. You can't just set a variable and just leave it, right? Something must be attached to it. So that is it. So this simply means that a variable must have a name and a value. So let's go straight. So there are rules to how you can name a variable in Python. You can't just, start writing whatsoever you feel like you want to name a variable. No, there are rules to it. Rule number 1, a variable cannot start with a number. You can't say like A22 is equal to, no, that's not going to work. That's going to bring up a syntax error. So a name of a variable must begin with a letter, right? Rule number 2. Python is case sensitive, meaning A is not A. So if you put 2 variables, you say A, you put the other one in lowercase, the other one uppercase, it treats it as 2 different variables, not the same. So Python is case sensitive. So you cannot set a variable name to a Python reserved keywords. You can't name a variable int, you can't name a variable float. That is just it. So underscore is the only special character allowed to be used when naming a variable. So you can use underscore to start up the name of a variable. That is the only special character you can use. You can't use asterisk, you can't use minus and all of that. So let's just open up our Python file and just give you some brief example. So you can have a variable started with 22 and say 22 is equals to a string called name. This won't work, right? So just go ahead and print that on the console. You're going to have error. You're going to have a syntax error there. So you say cannot assign to literal here. Maybe you mean equal to, I don't know. But the issue is you can't start it. So if you want to use this, you can start it with, let me say, an underscore. So underscore 22 is equal to name. So if I go ahead and run that, it's not going to give me any error. But I'm not printing anything out on the console, trust me. So I shouldn't have any error. So as you can see here, we don't have any error. So this can be done. You can use an underscore. You can, you can say name2. You can add, numbers to it and set it equal to whatsoever. John. So this is just basically, conventions that you can use in Python. to name variables. So this is just it about variables, just having a variable and having a value attached to it. So this is the variable name. So there are conventions like best practice. You shouldn't be naming something underscore 22. Trust me, that will put you in a lot of trouble. So you should have a convention like my name, you understand, number one, number two, you get. So just try to use a convention, something that is logical, something that is readable, and not something that will make your code confused and haphazard. So that is just it. So let me just go up and bring back the slide and see what we have next. So our comments in Python, I think should be our last video, our last topic in this video before we move to the third part. So what is basically comment? Comment is basically used in Python and other languages to explain a code, right? You want to attach something to your code to explain it, what does a code does and all of that. So you can just use comment. So let's go back to our file. I think I've used comment before. So for example, name one John, I can just attach a comment and say this is like John's name. You understand? This is like John's name. So this is just a comment. I don't know. You can just use it to explain a code. For example, outside of you using the hash sign, you can use triple quotes if you want to have like a lot of write up. This is still a comment. It won't show in our code like this is a comment. So even when you try to print something like, let me say print hello, this will not appear in your code. Trust me, it's not going to give any error. If I type something that is not supposed to be typed, this won't print out anything. You see my console, it's gonna be very empty when I run this because I don't have anything to be printed on the screen, right? So let me go ahead and run this so you see yourself. So as you can see, there's nothing happening here. So this is basically a way you can write comments in Python. You can use a triple if you want to have large text like lot of text in it, you can do this. If you just want to attach something simple, you can just use this hash sign here and just write your comment. So this is how you do comments in Python. So this is just it for this video. You should endeavor to like and subscribe to this channel, share with your friends and family, and recommend this video. See you in the next tutorials.